Alright guys, welcome to this page of the notes. What we're going to do is we're going to start taking a look at that second objective or learning target, which is solving logarithmic inequalities. Now, the rules that I've got for you are a little bit more complicated, but I promise I've got a great way to sort of help you keep them straight and kind of figure out how they work. First, let me highlight the rules for you, which I know is an incredibly complicated looking thing. Just know that there are two different rules depending on whether you have a greater than or a less than symbol in your logarithmic inequality. And I'll explain why we have two different rules depending on which inequality we have here in just a second. The first one, if you have a logarithm where the logarithm is greater than y, then when you rewrite it as the exponential, the value of x will be greater than the exponential b to the y. However, if you have a logarithm that is less than y, when you rewrite it as the exponential, your x will be less than b to the y, but has to be greater than 0. We have to add this extra little bit here, and here's the reason why. It's because x less than 0, well actually less than or equal to 0 must be excluded. Remember, you can't take the logarithm of 0 or a negative number, which is why this extra little bit right here, this x greater than 0, is necessary in this second rule. Let me explain it to you this way. I think this will make a lot of sense to you. Let me draw you a couple of number lines. So here we go. I'll draw a quick number line right here for our first rule and a quick number line for our second rule, okay? Let me put a couple of points on our number line. There's 0, there's -1, and let's say that this guy right here is b to the y, whatever that happens to be, right? B to the y will be some number. Same thing for our second rule. Let me put a 0 on here. There's a -1, -2, and then over here somewhere I have a b to the y, right? This will be some number, but it'll be some positive number. Now, here's our first rule. The first rule says, right, if you're given this logarithm, it'll be rewritten as the exponential where x, what I'm trying to solve for, is greater than b to the y. Well, that's no problem. If b to the y is over here and I need everything greater than b to the y, well, here's what that means. I'm going to have b to the y and everything greater than it, which means there is no risk whatsoever. If the logarithm is greater than y, there is zero chance of me getting 0 or a negative number because I want everything bigger than b to the y. I want everything positive. But look at the second rule. The second rule says that the logarithm, log base b of x, is less than y. And here's why I need this extra little bit in the second rule. This tells me that x is less than b to the y. Here's what that means. I have b to the y right here. I need everything less than b to the y. However, I cannot take the logarithm of 0 or a negative number, and so I have to remember to add this extra little bit, which says I've got to stop right here. I can't take everything less than b to the y because then I would get values of x that give me a negative number in here, and your calculator will absolutely lose its mind, and at this point you should know you can't take the log of 0 or a negative number. And so that's why rule number 2 has this extra little bit in it that x needs to be greater than 0, so that you only take the values right here that are part of the domain of the logarithm. And remember, the domain is restricted because if you were to graph it, there's a vertical asymptote that restricts the domain of the logarithm. So that's why there's two separate rules. As long as the logarithm is greater than whatever this value of y is, no problem. I want everything greater than b to the y power, that exponential, and I'll never run into an issue. But if you ever come across a logarithm that is less than y, you've got to remember you're going to have to restrict the domain because I don't want 0 or any negative numbers. I can't take the logarithm of 0 or negative numbers. So let's go ahead and look at a couple of example problems and show you how these two properties are going to work when actually solving a problem. The first one I've got for you is right here. Log base 3 of x is greater than 4. Okay, no problem, and here's the reason why. I have the log base 3 of x is greater than 4. Well, log base b of x is greater than 4, or greater than y, is my first property, and I'm only going to be taking things that are greater than the exponent b, or the exponential function b to the y. I don't have to worry about 0 or negative numbers. So I'm simply going to use the snail method to rewrite this guy as the exponential 3 to the 4th, right? And then I've got my x over here, right? So the way it works is 3 to the 4th power, you come around to the x, and then all you need to do right here, the x is greater than 4, so when you rewrite it as an exponential, you just need to make sure that the x stays greater than the exponential. Since x is greater, x needs to be greater. It looks like, please don't get confused here, it looks like I've flipped my inequality. I haven't. Look very carefully at it. X is greater. When I rewrite it, x is still greater. I haven't actually flipped my inequality. I've just made sure my inequality stays the same. What I don't want you, the trap I don't want you to fall into is for you to fall into this trap. You look at it and go, oh, it's a greater than symbol, and so you come over here and put a greater than symbol. Please don't do that. In this case, you've actually flipped that inequality. The x was greater than, but if you look at what you've just written, now the x is less than. You flip the inequality, and please don't do that. So just make sure when you're doing these logarithmic inequalities, you carefully look at whether the x is greater than or if the x is less than. In this case, x is greater than, so make sure that x stays greater than, okay? Well, now it's really very simple. What is 3 to the 4th power? Well, 3 to the 4th power is 81. So I have 81 is less than x, or x is greater than 81. X is greater than 81. Again, you could just leave that inequality, or I may ask you for set builder notation. Set builder notation is really popular on the standardized test. And remember the way it looks, it's all values of x, and then we use the bar that means such that x is greater than 81. And then you close your little bracket. So whether you use inequality notation or set builder notation, whatever, be comfortable with either of them. Next example problem is this one right here, and once again, no problem. I don't have to worry about it because I have the logarithm is greater than. So I don't have to worry about 0 or negative numbers. I only want things greater than the exponential function. So we're going to use the snail method to rewrite this guy as the exponential. So it's going to be 4 to the 3rd. There's my x, and then be very, very careful. X is greater than or equal to. So when I rewrite it, I need my x to be greater than or equal to. Please do not switch that inequality, right? I haven't flipped it. I've made sure it stays the same. X is greater than or equal to. X is still greater than or equal to. Now, 4 to the 3rd is 64. So I have 64 is less than or equal to x. Please feel free to turn that around so that your variable is on the correct side. X is greater than or equal to 64. That's the inequality. Please be comfortable with set builder notation as well. It's all values of x such that x is equal, or x is greater than or equal to 64. Set builder notation. All right, I got one more for you here on the next page. Let me hop over and we'll do this one right here. And now we've come to one where we have to worry about that second property. Please notice the logarithm is less than 4. I now need to worry about 0 and negative numbers, and let me show you how to do it. Of course, we're still going to use the snail method. So snail method, oh, sorry, hold up. My arrows got weird. I start with the base and I work my way around the equal sign, and so it's going to be 2 to the 4th power, and then I have my x. My x needs to be less than this guy, so please make sure that you keep your x less than. Now, 2 to the 4th power, of course, is 16. Let me turn that guy around. And you need to remember, okay, I need all values of x that are less than 16. But I cannot do the log of 0 or a negative number. And so now property number 2 becomes very important. You need to remember to put in that little bit that says, but I need to keep x positive, so I need everything greater than 0. Right? And remember the way that that works on that number line. If I were to draw the number line here real quick, I've got 16 over here, I've got 0, and my negative numbers over here. What this guy is saying is I need everything strictly less than 16. Everything less than 16. Right? Everything less than 16, which would include 0 and negative numbers. But you know you can't take the log of 0 or a negative number, so you've got to add that extra little bit that tells me, hold up, you need to stop right there, restrict the domain, don't include 0 or negative numbers, and I only need just those guys right there on the number line. Of course, be ready to write it in set builder notation if I ask you for it, which of course would just be that. Okay guys, that's how the properties of, or the equality properties of logarithmic inequalities work. There are 2 rules. Hopefully why we have 2 rules makes perfect sense to you now. You get lots of practice in the homework. You just need to remember if the logarithm is less than, you have to restrict the domain. And we do that by setting x greater than 0. Head on over to the next page of the notes. We'll look at a couple more problems dealing with logarithmic inequalities. I'll meet you guys over there.